In this question, we are going to take a look at applications of the cross product to finding the equation of a plane through given 3 points. First thing we're going to do is find vectors PQ and PR by subtracting the coordinates of point P from point Q. We get -1, subtract -4, then -3, subtract -3, and -4, subtract -5. Okay, so a lot of negatives here. So this is really -1 plus 4, which is +3. This will become a 0. This is -4 plus 5, so that's 1. Now, if I want to find vector PR, I will subtract the coordinates of point P from R. -4 subtract -4. -7 subtract -3. And -10 subtract -5. Okay, so this looks like that's 0. This would be -4, and then this would be -5. Okay, so let's do that. Now, to find the cross product, we need to form a determinant with I, j, k as the first row, then the first vector that I got as the second row, and the last vector as the third row. Now, I'm going to do an expansion over the first row, so I'll take the I component, and I'm going to multiply that by a determinant that will be obtained by crossing out the row and the column where I is. So this will become 0 times -5, subtract 1 times -4. And then the jth component comes with the negative, and you want to cross out the row and the column where j is. It will become 3 times -5, subtract 0 times 1. Finally, the kth component is obtained by crossing out the row and the column where k is, and it is taken with a plus. It'll become 3 times -4, subtract 0 times 0. Now, in summary, this looks like the first component is a 4. The last component is 15 because this is a negative and there is another negative here. Then this one is -12. Now, to check my answer, and I always should check my answer on the test, on the homework, I need to check whether the cross product, and let's call it W, whether if I dot it with each of the original vectors, I would get 0. So if I multiply 4 times 3 plus 15 times 0 plus -12 times 1, I will get 12, subtract 12, which is 0, check. Now I do exact same thing, and I'm going to find the dot product of this one of my answer with the second, and it better work because I've already done so much work. So 4 times 0 plus 15 multiplied by -4, and then plus -12 multiplied by -5. So this will become -60, and then this will become +60, and that is 0. Check. Okay, I got the cross product correct. So I got 4, 15, -12. All right, but that's not the final answer, because what I wanted the cross product for is I wanted to write down equation of a plane. So for equation of a plane, I need the following. So the formula looks like this: a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. So what is ABC? ABC are the components of a vector normal to the plane. So it's perpendicular to the plane. So if you think of this as a plane, vector n would go perpendicular to any vector that lies in this plane. And that is the cross product. So A in my case is 4, B is 15, and C is -12. If you want to ask what is x0, y0, z0, this should be any point that belongs to that plane. So you take your pick. I'm just going to take P. And I will get 4 times x, subtract -4, which is the same as plus 4. then plus 15, then I would get y plus 3 because again I'm subtracting negative, and then minus 12 z plus 5, and I should get 0. Now the final answer should be completely simplified. So I get 4x plus 16 plus 15y plus 45 minus 12z minus 60 equals 0. So 4x plus 15y and minus 12z. Okay, so what is left? So I got 16 plus 45, which I think is 61, minus 60, I think that would be positive 1. So that would become, if I move it to the other side, I think that would be negative 1. Now, how do I know if this is right? So what you can do is you're going to have to substitute each of the original points into the equation of the plane and see if the answer is correct. So I will say, okay, let's say x1, let's take the first point. The very, very first point we started with. So what was the first point? Minus 4, minus 3, minus 5. And I want to check if the equation I got, if it's really going to work. So I get 4x1 plus 15y1 minus 12z1, and I got negative 1. So that's good. Okay. For the second point, I had negative 1, negative 3, negative 4. And that's also negative 1, so that works. And then for the last point, I have negative 4, negative 7, negative 10. And that works also, so I know for sure that my answer is correct. Okay. The next question says, find the area of the triangle PQR. Now that's actually pretty easy. So the area of the parallelogram that has PQ and PR as adjacent sides is the magnitude of the cross product. If it's a triangle, you just have to divide it by 2. So I will have the calculator right here, and I'm going to find the magnitude of the cross product by squaring each component and adding them up. And that gives me 385. So I will take the square root of that to get the magnitude, and I divide it by 2 because that's a triangle. Okay, finally, I want to write down an equation of a line that goes through point Q and parallel to vector PR. Whenever you write the parametric equations or vector equation of a line, you have to start with the point. And the point is Q. And Q was negative 1, negative 3, negative 4. So that'll just go here first. And then you add number t, with number being the vector that shows direction of the line. And they say that that vector is PR. So PR was 0, negative 4, negative 5. So this should be something like 0t minus 4t minus 5t. Now 0t I do not need to put because that's just 0. And that's this part. We're done.